This is what we're going to do today. I got to look at the screen here. Okay, so you can see this is what's called a HAR cascade. And around the blue, that's a face detection. And then the green is the eye detection. And sometimes it picks up my mouth.
Only you were shaved.
So this cascade was actually developed by Intel. And I'll show you how it works. So what we're gonna do today is create a custom cascade. And what I've chosen to do is detect a watch. And I actually had a bug. Maybe you guys can help me figure out what I did wrong. I know what I did wrong, but that's what you gotta tell me what went wrong. So what I'm gonna do is take this watch and detect the watch in the image. This is Apple Watch. So if I did this right, it should put a box around it. And I also put some text on it too, where it says watch. By the way, I followed along with the guy named Harrison on StinTech's YouTube channel. So you can get all of his stuff. He did a much better job. Actually, go check him out. He describes it better. But I was just doing this as for fun to go along. So let me show you how it works. Okay, so here's the prerequisites. You need Python 3.4, Python 3.6. I could not get to work with OpenCV. So Python 3.4.1. You install pip, you install NumPy, Matplotlib, and CV2 with pip. And the CV2 you actually have to download by going to opencv.org. And you download the version of Python that you're on 3.4. Then what you do is you download the face and eye cascade. That's what I just showed you from Intel. It's just like a really small XML file. And then what we're gonna do is create our own. And then I'm gonna show you a few different Python functions on how they work. And then ultimately, hopefully detect the webcam.
So under IDE, I'll set the version of Python.
Oh yeah.
Look that up on the internet. So often we find the latest one.
I forgot to set my timer. There's learning. I'll show you how you train a model. It's kind of an AI, but more machine learning. Okay, so first we're going to detect. Let's see. Okay, you download the HAR cascades from GitHub. That's what I've already done, and then build the Python program. So why don't I show you that real quick? So here's the function that I just showed you. So here's the face cascade that you download. It's just an XML file. And here's the eye cascade, another XML file that you download. And then you do capture, video capture. This is 0, that's the webcam. And what else? I think there's a couple for loops here. Basically what you're doing is, it's pretty easy. There's not really much to explain here. You're basically just displaying the cascade and the MShow. Here's the CV2. So this is where you're using OpenCV to show it. And then you release it and show the windows. So that's kind of the basics of that. Okay, and then back to here. Okay, so this is how you create your own. You gather negative images. So I use a source called ImageNet, which has, and there's also one called WordNet, which is just a plethora of images out there. And what you do is you go grab 1,000 random images, it has people, it has whatever in there, and then you superimpose to create your own positive image. So I took a picture of the watch, and then I overlaid that onto 1,000 of the negative images and created 2,000 negative images and created 1,000 positive images. I think I actually got that wrong. 1,000 negative and then created 2,000 positives. Does that make sense? So yes. 1,000 of random images, created the watch inside of there and created 2,000 positive images. And then what it's going to do is going to train against that. And that way it can basically say, detect that watch from the negatives.
So you have one watch,
yeah.
1,000 images from the same watch.
Yeah, so I take, here, I'll show you the picture that I took of my watch.
The same angle too.
It actually kind of moves the angles around because it'll be, yeah, if you move the watch like this, it'll detect it there that way too. So it's a 50 by 50 by 50 pixels. I just took a picture of it, of the watch. And you can do other images, any image you want. And that's part of the problem. So that's part of the problem I'm gonna have. Okay, so let's go through the steps on how you train the cascade. So there's prerequisites. It didn't actually work on Windows, so I had to do it on Linux. And here's the things you need. You gotta upgrade your Linux and get Git, those are basics. Then you install the building. And then you install the,
Oh my.
yeah, there's a,
Okay.
yeah, this is all one packet. Well, there's several packages you have to get, yeah. Yeah, and then you'll see, so if you follow along, you can follow along his videos. He has like a series of 5 videos where you just install these packages, and then it basically builds the prerequisite. So then eventually you're going to get to the OpenCV library. That's what you need.
That long?
It didn't take too long. It probably took me, I probably worked on this for 2 evenings, probably 8 hours.
So I would suggest training on AWS free servers.
Oh yeah, I did this on a Google server. Yeah. Okay.
Learn how to create ad hoc servers.
All right, so then what I did was run the program for negative images. So what it does is this program goes out and it goes to ImageNet and collects 1,000 images and then stores it in a folder called negative, and it just numbers them 1 through 1,000. And they're set to 100 by 100, and it changes them to grayscale. And then what we have is this bg.txt, which is basically the info file, the table of contents type of file. And then you create your positive images. So you're going to basically create a new folder for info, and you're going to take the negative images, and you're going to take your watch picture, and that's where you're going to superimpose those on there to create your positives.
How you take 1,000 pictures?
I'll tell you in just a second. That'll be the next step.
I have to know.
Yep, that's the step I'll show you. Lastly, last step is remove outliers. So a lot of these actually came from Flickr too, where it comes back with a bad result. You get like an error or a bad image or one that doesn't really make sense. So what you can do is you can take that image, put it in a negative folder, and then you can compare your other images to say, this doesn't really match anything. It's just like a blank image. So you can compare that, put the blank bad images. So that's another program to run.
A Flick?
Oh, Flickr is it's like ImageNet. It's just a source of images that you grab from.
Oh, okay.
Yeah. It's yeah. Okay, so here's the commands. Here's how do you train your model. So first is you create the samples. So I think there's 3 steps. Yeah, the sample, the vector, and then your positive images. So you're basically taking the watch image here, and then you're taking the images, the 1950 images here, and then you're going to create, let's create the samples. And then you create this vector file, which is kind of like a reference to it. And then lastly is the train the cascade. This actually, I started it around 10 or 11 at night and ran till 9 in the morning or something like that. It took a while. I had 2 gigs of RAM. And so you run it with no hup. If you're familiar with Linux, it submits it to the background, and this ampersand basically breaks out of that session so you can come back to the line. But basically, yeah, you run this, and what it's doing is taking the images and putting in it. I wish I had a picture, I don't. But basically, you'll see the watch on top of the other images. Could be an image of somebody in a park or whatever. And then this last command I added was to clear your cache. So in Linux, it basically just fills up your cache, and your server's going to crash if you don't clear your cache. So if you add this to your cron tab, then it'll drop your cache and clear it out. And you actually do it for each processor. So if you have 4, however many you have. Okay, and then let's see.
So you're not using the TensorFlow?
This one I didn't use TensorFlow, no.
Okay.
Yeah. Okay, let's see. Oh, and then what it does is inside the info folder, it creates these stages.xml. So this watch.stage, this is similar to that Intel cascade. It creates this watch cascade. And that's what I'm going to take that XML file and move it back to the Python directory and run against it. So let me show you that, how that code worked. Oh, let me back up here to show you the build watch. A couple of the modules here. I think this first one here, yeah, this first one is to go out and grab the images. So here you can see it goes to ImageNet, and do we have a visitor?
Oh, somebody.
So we have go out to the ImageNet, grab the files, and then it's basically calling the OS working directory negative. Around that side. Take a peek through. Yeah. Pause for those that are, might be honest. Oh, hey, Manish. You're always 20 minutes. Good to see you. We're about halfway through.
Oh, really?
Yeah, I'm recording it, so you can check it out later.
So
Okay.
is that done the WNID? This is the image ID or what?
This over here,
Yeah.
this is a URL, and
Do you grab one image or oh, this is just the image link?
yeah, this image link, yeah, exactly. And basically in ImageNet, you can search for things like people,
Right.
and then it'll give you a whole ton of people. So this is like that hierarchy of people, or any random image. You can search for orange, and that URL, you grab that URL, and it's going to give you oranges, like random 1,000 oranges.
And so oranges and those images they can download.
Yeah, so that link, it was just all random images. It could be anything. And then I grabbed that URL link, and it gave me 1,000 images.
And that is, you download those images to your local?
Yep.
Or
So what you do,
they zip it and like download it.
yeah. So the next step here is you create a folder called negatives,
Yeah.
and you're basically going to grab those images and convert them to grayscale and 100 by 100. So that's the two things you do. That way they're all the same, consistent.
Right.
And then write it to the folder and enumerate through 1,000 images. So pick number 1, it starts there and it just goes until it ends. And then store the images.
Oh, okay.
And then here's the other function I talked about. He called it uglies, so basically the ones you don't want, outliers I call it. And that's basically, it's going to look, so what you do is you manually take a bad image, you put it in a new folder, call it uglies, and then compare that against the good ones, and then throw anything else out. So there's a handful of 4 or 5 that you don't want to compare against.
What about the blurred?
Yeah, bad images, yeah, right. Okay, and then I think this is the same function. Yeah, I was messing around, so that's a different one. Okay, here, create positives. I think this one is basically, this creates your BG file. So you take 1,000 images, you run through this, and you create this BG file, which is a descriptor. One thing that I had most of you guys might catch this, but when I took them from the server and then I uploaded the BG info file, it kept erroring and said bad in BG info file. It's because you have to transfer binary, and I was having problems transferring it. So but basically your BG file describes what your images are, where they're at, and it's kind of like the context. That's what this function is doing here. Yeah, it took a few times, but Stack Overflow is your friend. Okay, so let me show you the last function, and then you can tell me if I what I did wrong here. So this is the one.
That's right.
This is the one that detects the watch. Or at least we hope. All right. So there's it's kind of doing it. I don't know why. It's off to.
You got an offset.
Yeah, exactly. That's.
You got an offset. It's actually.
It's not.
What is the purpose of putting the offset?
So the purpose, I guess, well, number one is the reason for image detection, right, is for your cars or drones, they can detect things. and there's an enormous amount of data, like let's say a car, they want to see something on the road, they have to detect that. And so the reason I chose watch was just because I was following along with the guy on YouTube. And the problem I'm having that's part of it, yes. And I took this at 10:30 at night, and it's completely different image than it is at 1:30.
Oh, I see.
So it's not going to actually detect it as well. But
it's not detecting the time or watch or what?
No, because the needle image is different.
yeah, you missed the photo I took, but I basically took the whole bezel here. And that is what it's comparing against. So if I go back here, I'll show you the picture. Here's a picture. And that's what it's going to detect. I should have done something else, but
Just a little bit larger picture.
but it was, and it also matters, like Caitlin, like you said, if you have it at an angle or if you have it further back. So that's that sizing.
Well, your training, your watch was 50 by 50 and
Yeah.
your images were 100 by 100.
Yes. So you're basically, you want a larger image and then the watch to go on that image so it doesn't occupy the whole space.
It's occupying half the space.
Yeah, that's
fairly large.
it is large. Yeah. I don't know why it's so large. I think you really need a good sample set, a really good detection. Otherwise, if it's too small, I don't know actually why it's so large comparatively to the positives.
I was kind of saying, I was looking at
But
the guy that you borrowed this from.
yeah,
His isn't working so well.
at least you get the idea, right?
He's just a fraction of the watch. So he's actually detecting actually some of the face of the watch, not actually detecting the watch.
Oh, okay.
And so I think that's when it's showing on your hand there.
Yeah.
But there's a couple lines on your hand that look like it's a batch of watch.
Okay, and to Michael's point, if you want to go check it out, he's got a great site, pythonprogramming.net, which teaches a ton of machine learning, computer vision, et cetera.
Just
If you follow him for a few months, you're going to be a good Python programmer. That's how good a teacher he is.
Is that the name?
Yeah, Stendex. Just Google that, S-E-N, or put it on YouTube, S-E-N-T-D-E-X. There's that too, yeah. So that's it. We have some Q&A, so we can keep going. I'm going to stop the recording.
So here, I'll leave it.
Oh, yeah. Thank you guys for coming on St. Patrick's Day.
Yeah, thank you for all the free